Hi all, today we are going to discuss on the topic computer vision. Computer vision is a process by which we can understand image and videos, how they are stored and how they can manipulate and retrieve data from them. Computer vision is a base or mostly used for artificial intelligence. Computer vision is playing a major role in self-driving cars, robotics as well as in photo correction apps. OpenCV is an open source computer vision and machine learning software library. It is originally developed by Intel and later supported by William Garage and ITSys, which was later acquired by Intel. OpenCV provides a wide range of tools and functions that enables developers and researchers to work with the computer vision applications. OpenCV is a huge open source library for the computer vision, machine learning, and image processing, and now it plays a major role in real-time operations, which is very important in today's system. By using it, one can process image and video to identify objects, face, or even handwriting of a human. When it integrated with various libraries such as NumPy, Python is capable of processing the OpenCV array structure for analysis. To identify image pattern and its various features, we can use vector space and perform mathematical operations on these features. So these are the basic operations that can done in OpenCV. First one is loading and displaying images. Using OpenCV, we can use easily load and display an image with just a few lines of code. Here import cv2 image is equal to cv2.im.read. Im.read function it load a image from files into a numpy array, and cv2.imshow function displays an image in a window, and cv2.wait key function it wait for a key press, and cv2.destroy all windows function will close the OpenCV window. Next is basic image operations in OpenCV. Here we use two types of basic operations such as resizing and rotation. First one is image resizing. We use cv2.image resize function, which will resize an image to a specific width or height, and image rotation, which will perform the rotations with the help of cv2.get rotation matrix 2D function and cv2.wrap affine function, which perform image rotation with a specified angle around the center point. Here the given code which will show the how the resizing and the rotation will happen with the help of cv2.resize and cv2.wrap affine functions. Next is image filtering in OpenCV. Here we use two types of filtering method: Gaussian blur and image gradients. Gaussian blur in cv2.Gaussian blur function, which will apply Gaussian blur to reduce image noise and smooth the image. And by using image gradient, cv2.sobel function compute image gradients in the x and y directions, which are useful for edge direction. Next is image threshold in OpenCV. Image threshold, which will apply various thresholding techniques to create binary images by segmenting objects based on pixel intensity. We can see the code here below. Next is object detection in OpenCV. Here we load the pre-trained Her cascade classifier for face detection. Her cascade object detection, which means cvd.cascade classifier function and detect multi-scale function, which are pre-trained classifier to detect objects or face, etc. in images or video. Next is image feature detection in OpenCV. The key point detection using ORB or oriented fast and rotated brief. Here the key point detection cvt.orb create function and the detect and compute function, which will detect key points or intersect points in the image and compute their descriptors for image features matching. We can see the code here. Orb is equal to cvt.orb create function, and key point descriptors or equal orb.detect and compute of gray image node, which will detect key points and compute descriptors. And next is draw key points on the image. The key points image is equal cv2.draw key points image key points none, color is equal to 0 comma 255 0. flags is equal to 0. Next is image transformation in OpenCV. Perspective transformation or bird's eye view is used for image transformation here. Perspective transformation or CV2 get perspective transform function or CV2 wrap perspective function, which will perform perspective transformation to obtain a bird eye view of an object or scene. Next is image blending in OpenCV. Here we used a cv2.add weighted function which will blend two images by linearly combining the pixel intensities with the specified weights. Here the code given load a second image 2 is equal to cv2. I am read of image.jpg. Then resizing the second image to match the first image dimension. Then perform the image blending by using cv2 add weighted function. Here we use image alpha, image 2, 1 minus alpha, 0. In conclusion, OpenCV is a powerful library and widely used OpenCV software library for computer vision and machine learning tasks. It offers a comprehensive set of tools and algorithms and functions that enables developers, researchers, and engineers to work on wide range of computer vision applications. OpenCV's feature including image and video processing, object detection and recognition, feature detection and matching, camera calibration, machine learning integration, deep learning support, and simple GUI functionalities. Its wide range of capabilities makes it a valuable tool for tasks like image and video processing, object detection and tracking, image stitching and facial recognition, 3D reconstruction, augmented reality, and more.